Hi folks, in this video we talk about some more key FO equivalences. You've already learned about quantifier distribution, or DIST. This is how the quantifiers interact with the Boolean connectives. In this video we're going to talk about a few more essential equivalences. One of them is called Demorgans for quantifiers. It's like Demorgans for the Boolean connectives, because Demorgans in Boole had to do with how you push a negation onto a conjunction or a disjunction, and then you flip the conjunction to a disjunction, or vice versa. Well, when you push a negation past a quantifier, you flip the quantifier as well. So that's why this has a lot of similarities to the other De Morgan law. The other De Morgan law still holds, so don't forget that. In fact, everything you've learned previously from propositional logic, bool, and prop is going to hold. So if you do De Morgan's law inside the scope of a quantifier, we're still just going to call it De Morgan's law. Like, notice what we did here. I have an existential quantifier around a negation. If I distribute that negation onto this disjunction, so I flip it to a conjunction, then that still holds good inside quantifiers. Or if I do the Boolean definition of a conditional, like I have this Aristotelian form, all P's are Q, I could also just flip that to change that to its disjunctive form and negate the antecedent. All of that is still good. So don't forget, all of the equivalences you've already learned still hold in first order logic. There's a few other essential ones that depend upon the quantifiers that are different. So for example, null quantification has to do with when you can expand the scope of a quantifier. If, for example, the P here just stands for any random sentence that does not have an X in it. And so that's why if there's no overlap of the variables, if this X does not appear anywhere in the P, then I can expand the scope of my existential quantifier. In a sense, this existential quantifier is not binding anything in P. And so we say it's null on P. If it doesn't bind anything there, then you can just make it wide scope around it if you would like to. Similarly, the universal quantifier can go wide scope on anything which is irrelevant to it. Anywhere where it doesn't bind something, you can make it wider if you would like. Variable switch is also really important to understand. Basically, what that means is your choice of variable does not matter. The letter X, the variable X, is just like the word it in English. And you can just reuse it. Sometimes if you're talking about two different it's in English, you can create ambiguity, problematic ambiguity. And so in order to avoid that in FOL, we have different letters, but X just means it and Y means it. So if I say everything, all X is such that it has property P, or all Y is such that it has property P, those really are saying the same thing from a logical point of view. Now, why would you need different variables? Well, sometimes you're going to have a lot of quantifiers, and you're going to need to bind different variables so they don't, because they might have overlapping scope. So having variables at our disposal is important, and sometimes we're just going to be able to switch from one to the other with equivalence, as long as you're not binding anything different. Quantifier reorder, this is an equivalence that has to do with multiple quantifiers. I put it here just so you have all of these collected together in one place, but we're not going to talk about that until later when we've examined doing many quantifiers at once. Double negation, this is just your familiar law. I'm just telling you that it still holds inside the scope of a quantifier, no problem. Now, what do you do with these equivalence principles? Well, you might have a chain of equivalences where you're going to demonstrate that this top sentence is logically equivalent to the bottom one, and what you have to do is justify each transformation here, each link in this chain of equivalences with one of those principles that we've just learned. So pause your videos now and see if you can do this equivalence, citing from the example in those lists I just gave you. Okay, that was your last chance to try to do it. The first thing I do, and I highly recommend this, is translate your arrows into their Boolean form, because really, once you get to that fundamental Boolean form, it's much easier to manipulate things. So I did the Boolean definition of the conditional on both of these arrows at the exact same time. When you're doing these chain of equivalences, it's okay to do multiple instances of the same in one step, as long as you're just citing one principle, then nobody's ever going to get lost. Now, once we've done that, and I've showed you in red where these parentheses are, so you can see how this top one is really the same as the other one in a rewritten form. Well, now what we need to do to get to this conclusion is we need to do some grouping. We need to change our grouping. So we need to use associativity. Of course, yes, all the laws that you've learned previously, like I just said, still hold. So we can do associativity inside the scope of the quantifiers. So now I just moved my grouping from this disjunction to this disjunction. Once I do that, now I can apply Demorgans here. See, I took this disjunction and I changed it into a conjunction, and I factored out this negation. I'm doing Demorgans in the reverse order of what you normally see. But remember, equivalences go in both directions. That's the bidirectionality of the equivalence arrow. So I'm allowed to push this negation in, or I'm allowed to factor it out by the same law, by Demorgans law. Once I've done that, of course, now I can get to my final conclusion just by doing the Boolean definition again. Notice this, I did not use the Boolean definition twice here. So all I did, I only have one or sentence left. So I took that or and I made it an arrow. And of course, that requires negating the antecedent. Since I already had a negation symbol here, I can just drop that, and here's how I get my final answer. So here's the chain of equivalence principles that I needed in order to get from the top sentence to the bottom one. Thanks.